Okay, everyone. So let's start the class. Please switch on your videos, everyone. Okay, so let's start the class. Okay, so in the last class, we have done the numericals based on the second law of motion, right? So let me check if we have any, so you can say, any type of numerical left. Sure, do this question, everyone. I'm just sharing one question more. Do this question, everyone, fast. The answer? Farhan, what happened? Why did you switch off the camera? Please switch it on. So whenever you are in the class, please try to switch on your video so that we can interact facially. Okay? Please do let me know the answer fast. I got the first answer. That's a simple question. Okay, step 5 meter per second square अस्तित्व is it? Because 2 is missed in that.
Yes, sir, it's square. I don't know how
अच्छा
to.
ठीक, कोई बात नहीं, कोई बात नहीं. ठीक ठीक ठीक, चलो. Any answer, Safia? Farhan? It's a very simple question. Why guys you are taking so much time? चलो देखो कोई बात नहीं, लेट्स सी. Like this is a question like that will take only 30 seconds and you are taking almost 3 minutes. देखो, which would require a greater force accelerating a 10 gram mass or basically at 5 meter per second square, or a 20 gram mass at basically 2 meter per second square. Now let's consider this thing. Let's calculate the basically force in each case. So first mass is basically that is m1, that is equals to 10 gram na, right? 10 gram है तो हाँ 10 gram. ठीक है. So 10 gram, let's convert it into kg. So it would be nothing but divided by 1000. 10 divided by, so it will get basically it will be in the kgs. So this is nothing but 10 to the power minus 2, because this will cancel this, and 100 means 10 to the power minus 2 kg. Am I clear to all of you? And acceleration 1 is basically 5 meter per second square. Similarly, we will be basically writing the same thing for the mass of 20 grams, that is 20 divided by 1000 kgs, that is equals to 2 into 10 to the power minus 2 kgs. Okay. And acceleration in that case would be 2 meter per second square. Clear everyone? Please do let me know. Right.
Yes.
Now, how you will calculate the force using the simple force and force is equals to mass into acceleration formula, that is m1a1. Okay. Substitute the values over here. So that would be 10 to the power minus 2 into 5. So that will be in Newton. So it would be 5 into, so it is nothing but 0.05 Newton, right? Am I right, everyone? Yes or no?
Yes, sir.
Similarly, here F2 would be M2A2. Substitute the values over here. So that is 2 into 10 to the power minus 2 into basically 2. That is nothing but 4 into 10 to the power minus 2 Newton. So that is nothing but equals to 0.04 Newton. So now you can see this thing that 0.05 is greater than 0.04. It means that the force required for the mass 10 gram will be greater than the force required for the 20 grams. Right, everyone? So this is the value.
Yes, sir.
Please do let me know, everyone, if you have any doubt till now.
No, no, sir. Clear.
This is how the question is solved. Safia, Stitva, and Farhan. Clear?
Yes,
Let's
sir.
see,
Right.
does this question takes like 3 to 4 minutes? It's a 1 marker question.
Sir, 1 minute.
Right? It should like between 30 seconds to 1 minute. And even if you are practiced with it, we've done so many numericals, it should not take more than 45 seconds. Right? So
Yes, sir.
please improve your like basically timings for the questions, because that will basically going to hurt you in the exam. Because if you do not basically manage your time in the exam, so you are going basically you will be like in the basically exam, you will not be able to attempt all the questions within the time limit. Okay, so it's very, very important. Allow us a
Yes, sir.
second. चलो ये क्वेश्चंस देखते हैं. ठीक है, आज के हाफ क्लास में इसके क्वेश्चंस करेंगे और फिर उसके बाद हम लोग फिर करते हैं ये थर्ड लॉ ऑफ मोशन. चलो दैट्स ग्रेट. दिस इज द क्वेश्चन. Please do let me know the answer for this, everyone. Fast. I will give you 1.5 minute, like I can say 2 minutes, not more than that. It's okay. So I'm basically giving you 2 minutes because this question is very, very simple. And do let me know the answer for this fast. Last 1 minute. Okay, I got the answer. Okay, Astitva. Only Astitva has given the answer so far. What about you, Safia and Farhan? Chalo, there you go. Please look at the screen. A part. So question is, first of all, before starting, let's write the given thing. Question is saying that the mass of the body is 10 kg, right? So 10 kg. And the velocity increases from 4 meter per second to 8 meter per second when a force act on it for 2 seconds. It means that u initial velocity with which the object was moving was basically 4 meter per second. And v was 8 meter per second. Time taken would be 2 seconds, right? So first question is saying that initial momentum before the force acted. It means that the question is saying that before when the force was not acting, it means that the initial velocity was there. So that's what the initial momentum would be. So initial momentum that is equals to m into u. Yes or no, everyone? That would be
Yes, sir.
okay, m into u. So that is equals to 10 into 4. That is equals to 40 kg meter per second. Now tell me, is it a question that will take like 2 or 3 minutes to solve? Farhan, Safia, you didn't give the answer at all. Tell me,
Sir, I
is
was
it a
not sure.
question that
I was not sure the
okay,
answer was correct. sir.
No, okay, there goes Sophia. In this class, I do not judge the basically students by the answers. If you're getting the wrong answer, at least just you have to inform me, tell me. Like then I will be able to tell you that whether whether you are doing right or wrong. Right. So that's how I will assess you. But if you do not tell me, how would I know that you are getting the right or wrong answer? Where you are making the mistakes. Right. So always give the answer irrespective of the right or wrong. Okay? Farhan, but why didn't you answer? And the final momentum would be mv because the force acted after basically force acted, so the velocity has increased to 8 meter per second, so that is 10 into 8, that is 80 kg meter per second. Am I clear?
Yes, sir.
C would be gain in momentum. So gain in momentum means that how much momentum is gained by the you can say body in each second. So how you will basically calculate it, gain in momentum. Momentum would be nothing but basically change in momentum. Gain means that how much you have achieved. Like initial was this 40 and final was this. So it means that there would be a difference between the final and initial. So that is the number that that basically you have achieved, that the body has achieved, yes or no. So that is equals to 80 kg meter per minus 40 kg meter per second. So that is coming out to be 40 kg meter per second in 2 seconds basically. This is the gain in momentum that the object has gained, right? So what the question is asking per second, it means that we have to divide this number by 2. Okay? So gain in momentum per second, that is 40 by 2, that is nothing but 20 meter per second. So this is the answer. Isn't it force? Go. Change in momentum by time. Isn't it force? Only the question has changed the definition or statement, but actually it is asking nothing but the force, because change in momentum by the time is nothing but force. So so here by the question is asking momentum, so I'm not changing the unit, but this is nothing but the unit that is called the per second. So it would be again per second square. So per second square, because they go kg meter per second, you are dividing again with the time, that is, so it would be kg meter per second square. Okay, that would be kg meter per second square. So there is nothing but mass into acceleration. Kg is mass, acceleration is meter per second square, right everyone? So that's
Yes,
what it is
sir.
asking. Okay, so I hope this is clear to all of you. Please do let me know, Farhan, Astit, and Sarah of Safia.
Yes, sir.
Oh,
Sure, that's
Yes,
great. Okay, sure, that's great. Now let's understand the third law of motion, right? So basically in the last part we have done the numericals, because in the last week class we already have done so many numericals based on for basically F is equals to ma. So now like these kinds of like these will be the kinds of numerical that you will be having in your exams. Okay, now let's move to the Newton third law of motions. Okay, so and this is the last topic, as like I got the information that like you are not having the conservation of momentum in your exams. So it means that according to this, so that's the last topic for this, right? Am I right now?
Yes, sir.
yes, sir.
yes, sir.
Check it, chalo, check it. Okay, so that would be the case. Okay, So now let's understand what is the third law of motion. So when one body exerts a force on the another body, okay. So it means that the second body also exerts the same amount of force, but in the opposite direction on the first body, right? Means that if you are basically pushing the wall, if you are exerting the force on a wall, so the wall will also exert the same amount of force on you, on your hand as well, but in the opposite direction, right? That is towards you. Okay, that is towards you. Am I clear to all of you? Please do let me know.
Yes,
Yes,
sir.
sir.
Next is okay. So according to the statement, that is the action and reaction. There is an equal and opposite basically. To every action, there is an equal and opposite reaction. It means that if you basically exert some force on a body, so that body will also exert that amount of force on your body as well, but in the opposite direction. Am I clear?
Yes, sir.
Yes,
Okay.
sir.
Sure, that's great. Okay, now let's understand. There are some basically you can say questions that we have a conceptual questions. Safia, what could you please basically send the question paper basically on the official number so that
Yeah,
we
okay.
can discuss the physics part in the class, because that will basically benefits to all of you, right? So that we can discuss it a little bit, right? And you can also get the idea that where you have made mistakes or where you can improve, right? No, I'm not just saying that that is a thing that I just wanted to say. Like if you are like, I will not ask like tell like you don't have to tell me that, sir, I did the mistake right here. So just I'll be sharing the whole, you can say, scenario in the class itself, and you just have to basically look at the portion on which you basically can more like improvise more, right? So that is the thing. Okay, no need to worry, we'll discuss the question paper separately. I'll basically will discuss the question paper separately. No need to worry. Okay. So I
Okay.
just basically tell you that how to attempt the questions if the questions are given in this manner. Okay. Okay. Sure, that's great. So the question is saying that how do we walk? So basically, how do we walk? So basically, we when we walk on the ground, then our foot pushes the ground in the backward direction, and in return, the ground pushes our foot in the forward direction. And the forward direction, basically, that's why this reaction, that is forward reaction, is basically causes the movement of our leg. That's what we say as the, you can say, क्या बोलते हैं, that we are able to move, right? That's how we are able to move. And one more thing I've seen in the basically the revision test, that is like most of you have attempted the, you can say, the conceptual question, but the explanation is very basically very basic in, is in very basic language, like it is due to acts like equal and opposite reaction, but you have to tell the specific points na bacho, like this point is happening in this case, so that's why it is basically that's why we are able to move. So everything is written here, but you have like I haven't seen a copy yet, like those who have like that person has written some portion from the notes itself. Like everybody is basically preparing and all the things from your own, but the thing is that but you can prepare, like you can write the answer on your own, but the thing is that you are missing the keywords in the answer, and that will cost you marks. If you do not include your keywords, you can change the language. I'm not saying that only this language is acceptable. I'm saying that you are missing the keywords. That is the most important thing, because if you do not include the keywords, you are not going to get the marks. Okay. So please understand this thing, that if in this definition, in this language, all the keywords are included, you can basically a little bit modify it according to your language, right? But the definitions should have the basically keywords, so that the teacher is able to understand, yeah, you got the right answer or not. Clear?
Yes, sir.
Any doubt so far to anyone?
No, sir.
Chalo, that's great. Okay. Next is the why the basically gun recoils. So simple example, the reason is that the equal and opposite reaction. The thing is that when the bullet is fired from the gun, the force sending the bullet force is equals to the force sending the gun in backward direction. Because when the gun basically bullet is fired, so bullet will exert will go into the basically forward direction. But when the gun is fired, so that once the bullet is basically escaped from the nozzle, the same amount of force is exerted on the gun itself, right? So that's it's called the recoil of the gun. But due to the high mass of the gun, it's not basically it's not observable that like it will basically displace a little bit, but it will give you a little bit jerk on your shoulder, right? So that's why it is little bit like the displacement is not that much observable. Am I right, everyone? Yes or no?
Yes, sir.
Okay. So that's why it's important to use basically like in the trainings, you can say camps and all the things. Like basically supervisors are there so that they can they can help the person who is basically learning the shooting. Okay. Okay. Next is the flying of jet aeroplanes and rocket. This is one of the most, you can say, common questions in the exam. That how do we see, how does the aeroplane work? So the simple reason is that in the jet aeroplanes utilize the principle of action and reaction. In the modern jet aircraft, the hot gas obtained by the burning of fuel rush out of a jet through a nozzle. So when the hot gas is combusted, basically that's why it produces a kind of gas chamber in it. And when it basically escaped out from the nozzle, so it basically gives you a for basically the rocket goes in the upward direction and it gives the same amount of force in the backward direction when it basically escape out from the, you can say, nozzle, through that nozzle. So that's how the rocket and aeroplanes work. Okay, the equal and opposite reaction of the backward going gases pushes the aircraft forward at a greater speed.
Yes, sir.
Okay, sure, that's great. This is one of the like next example is the case of a boat and a ship. So basically, when we deboard from a ship, or when we basically not from a ship, basically like that this basically that pushing is not observable in the ship, but the boat it is much observable. So during the rowing of the ship, the boatman pushes the water backwards with the oars. Oars means chappu. In Hindi it's called chappu. Like how many of you know, like I know that Astit know Hindi. What about you, Farhan and Safia? Do you know this word chappu? Have you heard this thing?
Yes, sir.
Okay, that's great, that's great. Safran, what about you?
Yes,
Did
sir.
you heard this word chappu?
Yes, sir.
Chalo, that's great. Okay. Like that's a Hindi word. I don't know that what is the proper word for it in the very, like you can say, in a common language. But in Hindi, it's called chappu. Okay. And it's very common in Uttar Pradesh, like in North India, because I belong from North India as Astit also. So he understand that chappu is very common in North India. So I don't know the common word for it. But okay, so the water exerts an equal and opposite push on the boat, right? When you basically push the water backwards, you go in the forward direction. Like the swimming. Swimming also, you also basically push the water from the hands in the backward direction, but the body goes into the forward direction. Yes or no?
Yes, sir.
Chalo, that's great. Okay, so next is which makes the boat move forward. Okay, now when a man jumps out from a boat to the bank of the river as lake, the boat moves backward away from him. It means that when you jump from a boat, that the boat will move away from you. Basically, I've basically seen like experienced this thing when I was a trip on Kashmir Valley. So I have basically taken a ride in the boat. So when I was basically reboarding from that boat or basically coming out from that boat, so boat was very unstable at that time. I thought that I'll fail. Okay, so that's why when you basically jump out or basically come out from a boat, so that's why the boat goes in the backward direction. When you push the boat, na boat goes a little bit in the water and basically in the backward direction. So when you will go, so that's how you move forward. You move in the forward direction. Okay, so this is due to the fact that to step out from a boat, the man pushes the boat with his foot in the backward direction. The push of a man on the boat is the action, and the boat basically gives you an equal and opposite reaction. That's why the person is able to move in the forward direction, right? So the force exerted by the boat on the man is reaction. Clear, everyone?
Yes, sir.
Okay, that's a very important and very common myth that, like, I have seen this thing that many of the students have done this question wrong. This question was there in the revision test, right? So the question, like most of the students have basically written that always act on the same body and basically in the opposite direction. but that's not the case. It acts on different bodies. Suppose that if I'm pushing a wall, so I'm basically action is my hand on the wall. So the action would be the you can say wall on the hand. So both bodies are different, yes or no?
Yes, sir.
And the direction is opposite, obviously. It means that if I'm pushing the wall in this, the wall will push my hand in this direction, right? Clear to all of you? Please do let me know.
Yes, sir.
Any doubts so far to
Yes,
anyone?
sir.
No, sir.
No, sir.
Chalo, that's great. That's great. Okay. So this is what the third law of motion is. Okay, let's see something based on the third law of motion. Please do this question. I'm just pasting it. I'll only give you a moment. Analyze the question properly, then answer only. Okay? Because if you give me the answer in a very rush, so it is a possibility that you will get the answer wrong.
Yes, sir.
Analyze all the points, explore all the options, then answer. Just a second, I'm pasting it. So in the next class now, what we will do is that we will do some questions from the PYQs, right? So PYQs, or basically what we can do is that I'll try to find out some questions from the NCERT exemplars. Okay? So please be prepared with that. Just a second. Okay, Stitva. Okay. Okay, Safia. Safia, what about the 49th question?
Sir, I don't know.
Chicken. Farhan, I didn't get any answer from your side. Achha, Farhan is left. Achha, chalo, theek hai. Let's discuss this question. So which of the following situation involves this second law of Newton? A force stops a lighter vehicle as well as heavier vehicle which are moving. A force can accelerate a lighter vehicle more easily than a heavier vehicle which are moving. A force exerted by a lighter vehicle on collision with a heavier vehicle result in both the vehicles coming to a standstill. A force exerted by escaping the air from a balloon in the downward direction makes the balloon to go to upwards. Farhan, What's your answer for this case, Vijay?
Yes, sir.
Let me know in the chat. Chat.
Okay, sir.
Answer, Farhan. ठीक है. ठीक. No, it's Safia. It's Safia. Farhan, where is your answer?
Sir, I have sent it, sir.
I didn't get your answer. There is no answer in the chat, Farhan. Now I get it. For which question, Farhan? Like you didn't mention any number, like question number.
Sir, for that second one, sir.
For the second one, this 15th one. What about the 49th?
Sir, I will send that also.
Send it to me. ठीक है. Okay. Chalo, that's good. Okay, now let's understand. देखो, first is basically saying that a force can stop a lighter vehicle as well as a heavier vehicle which are moving, right? So a force can stop a lighter vehicle as well as heavier vehicle. Let's see. Suppose that, just a second. Suppose that a mass is basically 1000 kgs moving with an acceleration of 2 meter per second square. Another mass is basically 1 kg moving with a 2 meter per second square. Okay. Mass. Force applied in both the case are 5 Newton. Force applied in both the case are 5 Newton. So now tell me, this one is 5 Newton. So this force would be 2 Newton. That is basically car is producing, because mass is into acceleration, that is 2. And this is 2000 Newton. Now see, you can see this thing. Is it possible that this force is able to this force can stop this vehicle? I know this thing because 5 Newton is greater than 2 Newton. But this force is not able to basically produce these, it will not stop the vehicle, right? So a force, it depends on the heavy mass of the vehicle and the magnitude of the force that you are applying on the vehicle, right? To stop. So the first option is not basically matching according to the second law. Okay. Second
Yes,
thing is
sir.
that, okay. Second thing is that a force can accelerate a lighter vehicle more easily than a heavy vehicle which are moving. Yes, it is a basically exact thing, because we have studied this thing is directly proportional to F and inversely proportional to mass. It means that slighter the mass, greater will be the acceleration if same amount of force is applied on the body, right? Right. So this is the B. C part is basically saying that a force exerted by the lighter vehicle on collision. So whenever the word collision comes now, it means that it is conservation of momentum. So is it not? It is asking the Newton's second law. So it is not conservation of momentum. Next is the D part. A force exerted by escaping the gas from a balloon in the downwards direction makes the balloon in the basically moves the balloon in the upward direction. So this is a case of action reaction. Airplane jet case goes in this, and this is nothing but action reaction. This is third law of Newton. So only B option is the case which is basically applying it. Okay.
Yes, sir.
First you can say option is basically a little bit more basically aligning with the inertial law, right? So that's why only B option is the only correct option, that is basically matching with this Newton's second law of motion statement and as well as the concept. Please do let me know, everyone.
Yes, sir.
Okay, chalo, that's great. Next question. A fielder pulls his hand backwards after catching the ball. This enables the fielder exert larger force on the ball. So no, that's not the case. Reduce the force exerted by the ball because we increase the time to change the momentum. So that's why the force on the hand will basically get decreased. So this is B, right? Increase the rate of change of momentum. No, we do not increase the rate of change of momentum by basically pull our hands in the backward direction. Keeps the ball in hands firmly. Like, it's not the case. It is not the actual reason. So only actual reason is the B option. Am I clear to all of you? Please do let me know fast.
Yes, sir.
Yes,
Any
sir.
doubt to anyone?
No, sir.
Sure.
Yes, sir.
Sure, that's great. Just a second. Let me take one more question. Okay, do this question fast, everyone. Please do let me know the answer. Any answer? Okay, I got the answer by Safia. Okay. So let me write all the given values. Please solve. One 50 grams. So I'm going to convert it into kgs. Five kg. Okay, I got one more answer by Sitva. Check it. Is answer Farhan answer?
Yes, sir.
Is I'm checking. And ball is traveling with the velocity. That is initial velocity. 13 meter per second. V is 0. And time taken to stop
Sir,
the
can I
ball
change
would
the
be.
answer?
Sure. Okay, so we need to calculate the force. Okay. 90. ठीक है Farhan, answer.
Sir, 1 minute, sir.
Check. Do it fast.
Sir, I have answer.
Okay, sure. Farhan always mention the unit. How many times I've basically told you, please do not miss the units because physics is all about the unit. If you miss the basically units, so you are going to, like your marks is going to deduct. So there go. First of all, we need to find the acceleration because if you need to find the force, acceleration should be the first thing because force is equals to ma, right? That is, for acceleration can be calculated using the first law of equation. Sorry, first equation of motion. That is v is 0 because when the ball will come into the hand, it will basically the velocity would be stopped. U is basically 30 plus time is 0.05 a. Okay. So a would be sorry 0.05 a would be minus of 30. Okay.
Yes, sir.
Just a second. So a would be equals to कितना हो गया 30 negative 30 divided by 0.05. So this decimal will get cancelled. 100 will come here and this will cancel this minus 6 times. So this the acceleration is minus 600 meter per second square. Now see this thing, this is very, very huge acceleration. 600 meter per second square, right?
Yes, sir.
Okay. So this would be, so now we have to calculate the force. Force would be m into a, that is equals to mass is 0.15 into negative 600. That is negative. So there you go. Two decimals are there, two zeros are there. It means that it would be 15 into 6 in negative. That is coming out to be 15, 6 and 90. That is 90 Newton. This is the answer. Please do let me know everyone if it's clear to you.
Yes, sir.
In the out so far 21.
No, sir.
Okay. So that is very